This video is part 2 of our discussion on practice problems using the ideal gas law. Make sure you've watched practice problems part 1 and make sure you've had an opportunity to try these problems on your own before you watch the solutions in this video.
Question number 4 says, what is the temperature in degrees Celsius of 66.22 grams of methane, which has the chemical formula of CH4, in a 98.5 liter vessel at 864 torr? So once again, there's a lot of information in this problem that you have to stay very organized. We are ultimately looking to solve for our temperature in units of degrees Celsius. With the information that we have been given, we have 66.22 grams of our sample. We can't plug that directly into the ideal gas law, but we can do a conversion from grams to moles in order to be able to use that information in the ideal gas law. I've also been given a volume of 98.5 liters. And so liters are units that I use in the ideal gas law, so this I can plug right into the ideal gas law for my volume. I was given a pressure of 864 torr. I can't plug pressures in units of torr into the ideal gas law, so I will need to do a conversion here from torr to atmospheres. If I take my 66.22 grams of methane, I can convert to moles using the molar mass of methane that I can calculate to be 16.04. Remember that as you calculate your molar mass, you're going to take your atoms, so we have 1 carbon and 4 hydrogens, times the molar mass of each element. So carbon is 12.01 grams, hydrogen is 1.008 grams, and we're going to take 1 times 12.01 plus 4 times 1.008, and that gives us our molar mass of 16.04. So that when we do that conversion, we find that we have 4.13 moles of methane, and this is going to be N in the ideal gas law. For our pressure, we have 864 torr. On the front of this handout, you have a conversion factor between atmospheres and torr, and that relationship is that 1 atmosphere equals 760 torr. And so as you convert from torr to atmospheres, you find that your pressure is 1.14 atmospheres, and so this we will plug into the ideal gas law for pressure. Our volume was given to us in liters, so we can use that value as is. When we look at the ideal gas law, PV equals nRT. For whatever reason, when students are asked to solve the ideal gas law for moles or temperature, there are many, many more mistakes than when students are asked to solve the ideal gas law for pressure or volume. So make sure you do the algebraic manipulation correctly and use your units as a double check to make sure you've done so. When I solve this for temperature, that means I'm going to move nR to the other side of this equation, and that will mean that my equation becomes temperature is equal to pressure times volume over moles times R. So that as I plug in what I know to that equation, my pressure was 1.14 atmospheres, my volume was 98.5 liters, moles was 4.13, and R is a constant, 0.082057. So that as I plug all of this information into the equation and solve, make sure when you put this into your calculator, make sure you use parentheses for that denominator so that you end up dividing by moles times R. And when you do that, you should get 331 Kelvin. If we check our units, the atmospheres from pressure cancel the atmospheres in R. The liters in our volume cancel the liters in R. Our moles cancel the moles in R. And that leaves us with Kelvin, which is a temperature unit, which is exactly what we're looking for. So remember that 1 over Kelvin is equal to having units of Kelvin. So our temperature in Kelvin is 331, but this does not answer the question. The question that has been asked of us originally is to calculate the temperature in degrees Celsius. So the final thing that we need to do is take our temperature in Kelvin and subtract 273.15 to convert to Celsius. And when we do that, we get 58 degrees Celsius as our final answer. Question number 5 says, what mass of neon is present in a 25.2 liter cylinder with a pressure of 15.9 atmospheres at 22.2 degrees Celsius? So ultimately, we are going to be looking to calculate a mass of our sample. What we know from the information that was given to us is that we have 25.2 liters, and this is our volume. We have a pressure of 15.9 atmospheres, and we can plug that right into the equation for pressure. We also have a temperature of 22.2 degrees Celsius, and so in order to use that in the ideal gas law, we will need to convert from degrees Celsius to Kelvin. So if I take my 22.2 degrees Celsius and I add 273.15, I get a temperature of 295.4 Kelvin that I'll use in this equation. So this is what I will plug in for T. When I solve the ideal gas law for moles, PV equals nRT. Remember that students make a lot of mistakes solving for moles, and I will tell you that it's very, very important that you know how to solve the ideal gas law for moles. When you solve for moles, you're going to be moving RT to the other side, and that means that N is equal to PV over RT. As I plug in for pressure, volume, R, and T, my pressure was 15.9 atmospheres, my volume was 25.2 liters, R is my constant, 0.082057, my temperature was 295.4 Kelvin. Make sure you have this denominator in parentheses, and when you solve, you get 16.5 moles. This does not answer the question that has been asked of us. The question that has been asked was specifically the mass of our gas. For neon, the molar mass will come from the periodic table. 1 mole of neon has a mass of 20.18 grams, so that as I convert my 16.5 moles to grams, I get a final answer of 333 grams of neon. In question number 6, it says what mass of chlorine gas is present in a 5.50 liter vessel at STP. So for the information that we're looking for in this problem, we're looking to calculate a mass of chlorine gas. Chlorine is one of our 7 diatomics, and so we can't forget that. Its formula will be Cl2 as we do our calculations in the end of this problem. For the information that has been given to us, we have a volume of 5.50 liters. So that's our volume, and we can plug that right into the ideal gas law. We're also told that we're at STP. So remember that that stands for standard temperature and pressure. That means that our temperature is going to be 0.00 degrees Celsius. When I convert my temperature of 0.00 degrees Celsius to Kelvin, I'm going to get 0.00 degrees Celsius plus 273.15 gives me a temperature in Kelvin of 273.15, and that's going to be what I plug into the ideal gas law. Again, when I solve the ideal gas law for moles, I find that N is equal to PV over RT. Again, when I solve the ideal gas law for moles, I find that N is equal to PV over RT. Make sure you do that algebraic manipulation of the variables correctly. As I plug in all of the information, my standard pressure is 1.00 atmospheres. My volume that was given to me is 5.50 liters. R is my gas constant, 0.082057 atmospheres times liters per mole times Kelvin. My temperature at STP was 273 Kelvin. As I plug all of that information into my calculator, again, be very careful with this denominator. Make sure you use parentheses. When you solve, you should get 0.246 moles. This doesn't answer the question quite yet. The question that we need to answer is the mass of chlorine gas. So that means that in our final step, we're going to take our 0.246 moles of chlorine. We're going to multiply by the molar mass, and remember that that molar mass takes into account the fact that chlorine is one of our 7 diatomics. And when we solve, we come up with a final answer of 17.4 grams of chlorine.